All right, let's go ahead and dig in. So first of all, today, uh, remember that um, we on Monday we did the. I got to keep my days straight here with all this craziness. On Monday we did the quizzes over lots of different topics, and then the plan for today was we're going to take a look at the things that gave us the most trouble and talk about those and see if we can't get better in those areas. And then I want to talk a little bit about the reporting your progress for the Khan Academy and Mathagon and open up an opportunity to ask questions about those things. And then the last thing today, I'd like to hear what you want to learn more about, because that I think we can definitely knock out some of those things, and we know that if there's something that you're interested in that you want to learn about, we tend to pay more attention to that and engage more, and that's really what our goal is here, is to have a high level of engagement so that this is very much worthwhile. So that being said, let me go ahead. I'm going to stop sharing. Hopefully you enjoyed that little cartoon there. Has anybody ever had that situation where you it's charged enough that you can, or in general, it's charged enough that you can move from the location that you currently are in, because you're stuck to that charging. I certainly have experienced that from time to time. So let me stop sharing that part, and I will share the quizzes results, and we'll take a look there. So, okay, so now I'm sharing my whole screen, and we go here and here. Okay, so there were several that gave us some trouble here, and so I want to take some time and take a look at those and see if we can't get better. Good sakes. As soon as I start talking, I'm just like Mr. Yawns. Um, so uh, we'll just dig in, and we'll start from number 6 here and just work our way back through and talk about some of these things. So here we go. All right, number 6. It says x minus 6 squared, and if we click on it, we can see the things that people chose to see where we ran into issues there. The thing with this that we have to remember that students get mixed up with, and I'm gonna change my deal here. Oops. Helps if I do it the right direction. All right, so if I have x, let me change colors, that's kind of hard to, x minus 6 squared like that. Can everybody see that? Can you see my writing on the screen there? Okay, so if we have the x minus 6 with the squared, that means it's x minus 6 times x minus 6, right? And so we would have to FOIL that in order to simplify. So then it's x times x, which would be x squared, and then x times negative 6 would be minus 6x, then minus 6 times x again, so another minus 6x, and then minus 6 times minus 6 would be plus 36. Combine like terms, and we end up right there. What I see students want to do quite frequently is they just want to square each of these parts. The problem with that is we have this subtraction here. And when we have subtraction, we can't sort of distribute. It's technically not distribution, but sort of apply that squared to each piece. If it was something like this, 6x, and then squared, in that case, we would apply that squared to each piece. So we would square the 6, square the x, and that would give us 36x squared. Okay, so do we see the difference between those two things? I can see heads shaking, so that's good. We don't want to talk. Okay, awesome. Let me clear that out of there. And let's check out the next one. Oops, that's not, doesn't work the way I wanted it to there. So let me close that thing, back up here, and we'll go to this one. Okay, it says the inside of a microwave has a volume of 1,620 cubic inches. It measures 18 inches wide and 10 inches long. What is the depth of the microwave? Okay, so if we just think about this a little bit, the depth of the microwave, that would be how deep it is. So let's just sketch a little picture here. Maybe that'll help us to get in a clue or an idea of what's going on. So if we sketch our microwave, there's the front of it, and then it'll go back something like that. And then there's the back of the microwave, and something like that. So we know the volume, and we know that it's 18 inches wide. So right here would be 18 inches. Oh, sometimes this is a bugger. Inches, and then 10 inches long. So that's kind of a weird way to talk about that, but I would call that the height, probably. So this is 10 inches. And then the depth of the microwave would be this right here. We want to know what that is. So to figure that out, well, we got to know we're talking about volume. And remember, to get the volume, it would be volume equals length times width times height. That's one way to do it. And we know two of those things, the 18 and the 10. And so we could plug those in, and we know what the volume is. So this would be 1620 equals, I'm just filling it into my formula there, the length we said is, or it says is 10, and then the width is 18, and then the other dimension, the height and the depth and so on, we'll put in D for the depth, and then we multiply those two. So a lot of people got that amount right there, but that's just this multiplication. We're not quite done yet when we do that. 1620 equals 180 times D, divide by 180 on both sides, of course. And then we end up with D equals 9 right there. Okay. Questions on that one? And you might also think about, well, what makes sense? Would a microwave have a depth or any dimension as far as that goes of 180 inches? Does that make sense? I don't think so. 180 inches is a lot, and that would be a really, really big microwave. Okay. Any questions there? How we doing so far? Hanging in there? So far, so good? Okay. Is what I talked about so far helpful? No? Just, okay. All right, good. Okay, then let's take a look at the next one here. Moving our way up. All right, so this one it's asking us for the volume. And the formula for the volume of a sphere, well, guess what? Um, I put a formula sheet into our Google Classroom here. So if you go to classwork and then formula sheets right here, I put two different formula sheets, and I believe this one has both. Let's see, sphere, 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 right here. Okay, so volume of a sphere is 4/3 pi times the radius cubed. So let's go back over here. 4/3 pi times the radius cubed. Let's just write that on there so that we remember. So V equals 4/3 pi times the radius cubed. So this measurement right here is the radius, and so we just plug that in, and we'll have 4/3 times pi times 6 to the third, okay? And then I would say grab your calculator. So let's get our calculator here. Oops, I gotta get rid of that. Oh, curses. Okay, so I gotta erase the screen, unfortunately. So 4/3 pi times 6 cubed. Let's remember that. So let's do the 6 cubed first. So 6 to the third power is 216. And then we've got times 4/3. So we can do that in our calculator right here. So times, and I'm going to put this in parentheses. So 4 divided by 3, like that. Okay, so see how it's times the 4/3. This number right here is the 4 divided by 3 part. It hasn't been multiplied by the 216 yet. So if we say equals, now we've got that. So it's 4/3 times, or excuse me, we did the 4/3, we did the 6 cubed, now we got to take that number times pi. So times, and a lot of calculators will have a pi button, and right here is this one. So times pi, that number is pi, we have to hit equals, and so we get 904. And if we look here, and this number, the reason for the decimals being different is because they likely used 3.14 for pi rather than the pi button. If possible, we want to be as accurate as possible. So I would actually prefer this number to that one, but we can live with that. Okay. How are we feeling about that one? Good. I appreciate the thumbs up. Awesome. Thank you. Okay. So that's that one. Moving our way up here. All right. Domain and range. So for the domain and range, the domain, and it's just alphabetical. Okay, so D comes before R and then X before Y. So the domain is the X values, the range is the Y values. So as we look through here, what we can see is that we've got the X values, which would be 0, 1, 2, -4. Okay, and then the Y values would be 1, -3, -4, 1. So our domain again is the X values. So if we put them in order, -4, 0, 1, 2. So we see that, we look through here, right there. And then the range is the Y values, which would be 1, -3, -4, and 1 is in there twice, so we only have to write it once for our range. Okay? So there's our domain and range. That's one that trips people up quite a bit. Any questions on that one? Good to go there? All right, awesome. Let me just double check one thing really quick here. Okay. All right. Then moving on up we go. We have, okay, so for this one, it wants the sine of C. So sine is trig stuff, and trig functions. We have SOHCAHTOA, so ka toa. Okay, and S is the sine, C is the cosine, T is the tangent, and then the sine is the opposite side over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. So we look at our triangle, and in every, and this is only true for right triangles, the side that is across from the right angle, so this side, in this case, the 50, that would be the hypotenuse. That's our H, okay? And then depending on which angle we're talking about, we have either the opposite or the adjacent. And in this case, since we're talking about angle C, that's this angle right here, the opposite is the one that if we were standing right, like right here, that we are looking across at, that would be this one right here, okay? So that would be the opposite, and then the 48 would be the adjacent. The adjacent is one that, the side that makes up our angle C, that's not the hypotenuse. So see how there's two sides that make up that angle, and one of them is the hypotenuse, the 50. The other one is the adjacent. It's the other one that you could touch if you were standing in angle C there. So then we just need to look at the sine. We know what all of these are in relation to angle C. So sine is the opposite over the hypotenuse. So we want the opposite side, which was the 14, so it'll be 14 over the hypotenuse, which would be 50 right there, okay? And sometimes we'll simplify if we can. In this case, they didn't simplify, and so we just get this 14 over 50, okay? Any questions on that one? Hanging in there? All right. Let's get rid of that. Moving on up. Next up, find the volume of the solid shown by the figure. Round your answer to the nearest whole number. Okay, so this is another one where a formula is going to be handy to find the volume, and that shape is a cylinder. So let's look at our formula sheet here. That's the curved surface area. We need the volume of a cylinder. Hey, right here, okay, and if we zoom in on that a little bit, up in there, okay, it says pi r squared times h. Okay, so pi r squared times h for our volume of our cylinder. Okay, so I'm just going to jot that down here quick so that we remember that. So volume, find my thing where I'm writing, there we are. Volume equals pi r squared times h. Now, remember that a cylinder is really a type of prism, and to find the volume of a prism, we can think of it as little slices of our shape. So, like, we'd slice one through there, slice one through there. And so if we can find whatever the area of that base is and then multiply by the height, that would give us what we're interested in. So if I can find the area of that circle, then I just multiply by the height. Well, look at this. The area of the circle is right in that formula. Pi r squared is the area of a circle. and then we're just multiplying it by the height. So I think that formula makes a lot of sense if we know the pieces that make it up. All these parts fit together. So the radius in this case, well, this 12, be careful, that's not the radius. The radius would be half of that because 12 is the whole way across there. So in this case, we're going to fill in pi r, which is going to be 6. So 6 squared times h, which we know is 10, like so. Then we have 6 squared. Remember the order of operations. Don't multiply that first. We have to do the exponent. So 6 squared would be 36 times 10 would be 360. So we have 360 times pi. And we multiply those two things, and we would get right here approximately this amount. Okay? Clear that out of there. How we doing? So far, so good? Hanging in there? Okay? All right. Awesome. Let's keep moving up here. See what else we got. Okay. Now for this one. Ooh, this is a tricky one. So the key with this one is that we have to remember what that exponent is being applied to. So we've got that negative exponent, and that negative exponent means that we're going to have to flip part of it. But this, what we have written there, is not equal to
You showed it on my screen, Booby.
is not equal to that.
No, stop, Booby.
Do you have a question, Marissa? Oh, nope. Okay. All right. So these two things right here are not equal to each other. When we don't have the parentheses, that negative exponent is only being applied to the thing right next to it there. So it's only being applied to the x. A lot of people want to flip this, want to flip that whole thing like we see right there. What we do have here, okay, this is not equal. What we do have is the 5 is going to stay on the top, and just the x part is going to get flipped to the bottom. So x to the third, like so. So that would give us this one. Any questions on that one? Okay, so we got to be very careful in terms of what those exponents are being applied to. That can trip us up sometimes. All right. I can see a little boredom coming in on some people's faces. I hope I'm not boring you too much. Hang in there. All right. Next one. All right, it says, what is the range of this linear function? So as we look at the graph there, remember the range is the y values. And so we go to the lowest and then to the highest y value. And so the y value at the bottom, as low as it goes, is at 0 right there. And then as high as it goes, well, we got to count it up. 1, 2, 3, 4, 5, 6. So the highest it goes is 6. And so because we're including everything, all the y values exist between 0 right here and 6 right up here, we have to use an inequality that takes all of those. So that gets us this one right here. Okay. Questions on that? All right. Then let's keep moving up here. Next one, how do you find the volume of a prism? For this one, the most general formula is the big B times H, and the big B stands for the area of the base. So no matter what shape it is, this formula will work. It could be a triangular prism, a rectangular prism, and or so on. So we have to find the area of the base, whatever it is, and multiply that times the height. Okay. Anything on that one? All right. Keep moving up here. Ooh, logarithm. Okay. I'm pretty sure that you haven't seen this at all. Remember that, know that a logarithm is a way that we can write something so that we're able to solve for a variable up in the exponent. And so this one right here, the log base 5 of 25 equals 2. The answer to a logarithm is the exponent. So notice the exponent sitting right up here, the 2, is the answer to the logarithm. And the base is the base is the base. So this is the base 5, and this is the base of the logarithm 5. And so there we have it. This allows us again to calculate what the exponent should be if we have 5 to what power gives us 25. Okay, I would be willing to bet a lot of you haven't seen that yet, but that's something that'll be coming your way soon. That's an Algebra 2 topic. All right, let's see here. Let's do this. I feel like I might be pushing the limits in terms of your focus on the online meeting. So let's stop there for now. What I'm thinking that we'll do is I will give you a quizzes that's kind of similar to this one, and we'll see if what we talked about was helpful, and that we're getting better at those things. So we'll do that on Monday. We'll do another quizzes, similar types of questions, but to see if we got better in some of those areas. Okay, so that'll be our plan for Monday. Then back to our plan for today, the Khan Academy and Mathagon stuff. So what I did is, again, I'm not 100% sure the best way to do this, but I'm trying something. If this doesn't work well, we will adjust and take it from there. So if we take a look here, under week 2, you have basically 3 things to be working on this week. Several of you have already done taking this or watching this video and responding to that. So awesome job if you've done that. Thank you. And then there's 2 other pieces here. One is your progress in Khan Academy. So for that one, looks like a few people have done that already as well. We go view assignment here. We get this. It says post a screenshot of your current energy points on Khan Academy. And so to get those, see if I can get there here. Here's Khan Academy. If you click on Learner Home right there, then it'll show you your energy points right there. Okay. And my suggestion is that you try to shoot for like 1,000 per week, something like that. But if you don't quite get there, that's okay. I just want to see some progress from you. Okay. So for that one, all you got to do is post the screenshot and then you'll be good for that one. Or does that make sense? Does anybody have any questions on what I'm expecting there? You can look at anything that you want to look at on Khan Academy. Again, I would suggest previous math class that you have some things that you want to work on or review, or maybe your next math class, or look at some things that you find interesting that you would really like to learn about. And that's a great resource for that. Okay, good to go there? All right, then let me just hop back here. So go back to our classwork. The other one is Mathagon. And so for this one, we'll go to view assignment here. It says, please respond to the 3, 2, 1 prompts on the Google Doc regarding your progress on Mathagon this week. You used to be able to see, I'm going to show you here, you used to be able to see a score, a point value here on your dashboard, but for whatever reason, that's broken. So I just signed up as a student and I was trying to see what happened there. So I can't see that. So what I decided to do was I would like you to bop into this. And so I just ask you some questions here. So your weekly Mathagon progress, put in your name, the topics you looked at this week. So your topics, oops, that's not what I want. Your topics that you looked at will be right in here. You can see the things that you did. And then I would like you to put at least 3 things you learned. If you want to put more, that's awesome. Just tell me 3 things you learned. At least 2 things you found interesting that you didn't know before. That's the really cool thing to me about Mathagon, is that it puts it into a different context than you will often see in a traditional math class. And so 2 things that you learned or found interesting, and then at least 1 question or something you're curious about. Like, I'd like to learn more about this, or I wonder how this applies to something else. So 3, 2, 1, you perhaps have done that before. That's a somewhat standard thing that some teachers will use to have you look at things like that. So that's Mathagon. And I put a due date of Friday on these things. If you don't have it done by Friday, it's not the end of the world, but it would just be good to kind of keep you on top of things. If you need more time, if you need the weekend, whatever, that's certainly fine too. So do we have any questions on the Mathagon or Khan Academy stuff? Okay, and in terms of how much do I expect you to do in Mathagon, you need to do enough so that you can answer those questions, basically. So keep going until you find some things interesting, or until you've learned at least 3 things. And what I found is that students, and most of you have used Mathagon before last summer, and I find that students kind of get into it and enjoy and work their way through some of those things. So please do explore and look at it. You get out what you put in, and so if you only look at one particular thing and don't dig up much into it, you won't get a ton out of it. If you look at some more and really explore, you could get a lot out of it. So I would encourage you to do that. Does anybody have any questions on anything related to Khan Academy or Mathagon? Are we okay with those things?
I have a question.
Yes, sir.
Do we have to like submit it like every week, like a different one, like so you can see our progress? Or
Yeah, that's what I'm thinking. Just so that you don't put it off until the last week, and then it's like, oh, I got to spend 5 straight days on Mathagon or Khan Academy. I would like you to be working on it consistently throughout, just to learn stuff and see if there's some things that you find interesting and so on. So does that make sense? Is that all right? So just kind of breaking it up a little bit, and like I said, I'd like to see that progress and that you're spending some time with those things. So other questions on either of those things? Okay. If not, then we'll continue down our list here. So the last piece for today is, I wish I could learn more about. In terms of math stuff, what is there anything that you would like to learn more about? There's so many areas in math, and this is something that I think it might kind of encourage you to look at some things in Mathagon or in Khan Academy. because many topics are covered in both of those places. So I just want to open it up. You can either put it in the chat, or you can just turn on your mic and tell me about what do you wish that you could learn more about math related. If you're not sure if it's math related, you can still throw it out there, and I'll see if I can tie math into it for you. But what are some things you'd like to learn more about math related? Either in the chat, or you can unmute and talk about it. Don't be shy. Trig. All right. Awesome. Khan Academy and Mathagon have some good stuff related to trig. So definitely lots to do there. Proofs. Ooh, fun. There's a lot of logic there. And I believe Mathagon has some good stuff in terms of proofs. Also, Khan Academy would have some things in terms of proofs. Awesome. Some people want to be lawyers. I always think of lawyers when I think of proofs, because you're looking at different things and evidence to say that something is true. Factoring. All right. Factoring is a good skill, and that requires a really good knowledge of our multiplication tables. So we might have a little competition in terms of our multiplication skills as well. Polynomial factorization. All right. So factoring again, looking at those different terms and pulling things apart, and yeah, definitely awesome. Anything else? I'm not going to put anybody on the spot today. Solving quadratics with square roots. All right. That's something you'll definitely find in Khan Academy. You can look at that and practice there. Calculus. All right. Getting right to it. That Khan Academy has a lot of good stuff there. And if you want to know more, you certainly can. Centroid. I believe I saw something in Mathagon related to that. So you can learn more about that. Definitely. Anything else we want to throw in there? To me, that's a kind of cool thing about a situation like this and Upward Bound, is that we don't have stuff we specifically have to cover. And so we can look at things that you're interested in, and hopefully build your interest in math, and encourage you, build your skills, so that when you get back to high school in the fall, then you can do even more awesome stuff. All right. Like I said, I'm not going to put anybody on the spot today. Thank you to those who responded to that question. The remaining time today will be yours, and whatever other time you need. So please do be working on the Khan Academy and Mathagon stuff, and then that video that I asked you to watch as well. Once you've got those things all in good shape, report your progress on Khan Academy and Mathagon for the week, and go from there. Does anybody have any questions on what you should be doing for the rest of the week? Okay, if you do have questions, don't be afraid to send me an email. I check my email all the time, so go ahead and shoot me an email, and I'll be happy to help you with anything that you have questions on. All right. All right. fantastic. Have an outstanding rest of the week, and be in touch if there's anything you have questions on, and keep on keeping on. I look forward to seeing those assignments pop in and answering your questions and learning more about this stuff. All right. Have a great one. We'll see you around.